Okay, we were discussing about complex numbers. Allah. We'll continue there. Next problem. Find x and y such that -3 plus I into x squared y and x squared plus y plus 4i are conjugates of each other. Okay, so this means that you take one term and conjugate it, right? Both of them have to be equal, right? So this is what is given, right? So if I take a number and conjugate that number, I'm going to get the other number, right? They are conjugate of each other means that. So we'll see this is -3 plus I times x squared y, right? Its conjugate is equal to the other number. Other number is x squared plus y plus 4i. So let us try to conjugate the first number. Conjugation ಅಂದ್ರೆ ಏನು ಮಾಡಬೇಕು? The imaginary term ಇದೆಯಲ್ಲ, you have to convert that imaginary term's sign, right, into a different sign. Change the sign of that. Positive ಇದ್ರೆ negative ಮಾಡಬೇಕು, negative ಇದ್ರೆ positive ಮಾಡಬೇಕು, to the term which contains I. So this is -3. See, there is a plus I make it minus I into x squared y. So this is the conjugate, should be equal to the right hand side, that is x squared plus y plus 4i. So now we know that when we say that there are two numbers and those two numbers are equal and they are complex numbers, our intention is to show that real term of both sides are equal. Real term in the sense x square y should be plus y should be equal to this. And this also indicates that the imaginary terms are also should be same, both the sides. Then only you can say that those numbers are equal. Correct? So let's try to do this. This implies, so we'll do the equation. So equating real and imaginary terms on both sides. I come to know that. So I'm equating the terms marked with the red color. So that is x squared plus y equals -3. I get one equation. And the second equation, leave the I. Without I, you equate both sides. So on one side, I have minus x squared y. This should be equal to, on the right hand side, I have 4. On one side, you have -3 and another side, you have 4. All right, so we are equating these terms now. Okay, so let's just equate like this. So let's try to make a substitution now, because I need to write a x square. Wherever I see x square, this implies the x square should be equal to -4 divided by y, right? So I'll put this in the previous equation. So x square ಇಲ್ಲಿ ಕಾಣಿಸ್ತಾ ಇದೆಯೋ ಅಲ್ಲಿ ನಾನು -4/y ಅಂತ ಬರ್ತೀನಿ. This is -4/y plus y equals to -3. Okay, now so cross multiply and bring the terms to the same side. This means I multiply the whole equation by y. This is -4 plus y square and right equals to -3y. So y square plus 3y minus 4 is equal to 0. All right. So if you try to find the roots of this equation, you're going to factorize Madakagite. Straightforward, you can write it as this is y plus 4 and y minus 1 equals to 0. So the result is that y could be equal to either minus 4 or plus 1. Okay. Now I need to identify what values of uh, y are going to match. So when y is equal to minus 4, right, you can see that x square is equal to y by minus 4 by y. So this implies if y is equal to minus 4, this implies x is equal to x square is equal to minus 4 by minus 4, that is equal to 1. So you can have x equal to plus or minus 1. This implies x equal to plus or minus 1. Okay. So when if I say y equal to 1, this implies x square is equal to minus 4 divided by plus 1. So this is equal to minus 4. Now you see that this is not possible because x and y cannot be imaginary. So in the whole equation, we are supposed to find x and y such a way that the whole two terms which we are considering here, right? One is this and one is this. They have to be conjugates of each other where x and y have to be real. So this case, if you consider this x square is equal to minus 4, x is equal to root of minus 4, once again they become imaginary, right? That is not possible. So you can simply say that, right, this particular y equal to 1 is not possible. So the required answer is y is equal to minus 4 and x is equal to plus or minus 1. All right, so this is the required answer. All right, moving on to the next question. Okay. All right, let's move on to the next concept first before we solve some problems. All right, so this is a representation of a complex numbers in various forms. So this is various forms of the complex numbers. All right, the first format, it is what we are already using, right? This is called as the Cartesian form. Right. If at all we see z is equal to x plus or minus I times y, right? Where the x comma y belonging to the class of real numbers, right? Then we call this as the Cartesian format, okay? And I is equal to root of minus 1. So always we are going to use the standard format like this, and we will be using this technique for the representation of this. Okay, now moving on. This is what we already know, right? So every point will be considered as a point in x and y in terms of x and y axis. X is the real axis y is the imaginary axis. Okay, let's try to look at that like this. Say this is the x-axis, this is y-axis. If I try to write a point over here, right, and we are going to call this is z is equal to x plus I times y, this always indicates that, right, I am moving a distance x along x-axis and a distance, say, y along the y-axis. So using these representation, right, if you are able to represent a given particular point in space, and we call that point as a complex number, this is x and y coordinate system, so it's called as Cartesian form. So there is always another name for this. That name is the geometrical representation. Geometric representation of a number. Okay, standard format number 1. Then the format number 2 is called as the polar format. Okay, this is also called as magnitude dash argument. Magnitude argument format. So different books call it by different names. So the common name which we are going to use now is this. Okay, magnitude argument format, polar format, or it's also called as modulus argument format. Okay, so this is also modulus dash argument format. So what we do here, we try to first let's look at the difference between the two formats which we just now have discussed. So first format that is the Cartesian. First let us assume that there is a Cartesian format with this. So Cartesian format in the sense I need to have, there is a x axis and a y axis. Let us consider that there is a point, and this point is z is equal to x plus, say, I times y. So this actually means, right, I have to move so much distance along x-axis, so much distance along y-axis. Okay, so let's mark them. So let's assume that this is the distance I am moving along the x-axis, and say this is the distance you are going to move along the x and y axis respectively. So this is the point z. So this is the distance x, this is the distance y. Now I can actually reach the same point, right, z, without moving along x-axis and y-axis, right? Without doing that, let me assume that I take a straight line connecting the origin to the point. Okay, this is the new coordinate system. See, this distance is what I am going to call that as r. And also I have another angle that I can measure with respect to this x-axis. Let's call this as theta. So take a distance r, right, from origin and rotate it by an angle theta from x-axis. So that means this line will be somewhere here initially, right? ಈ r ಎನ್ನುವುದು horizontally ನಾನು r ಅಂತ measure ಮಾಡ್ತೀನಿ. Then I rotate it by an angle theta, right? So that means you are still able to reach the same point z. That's what is the meaning, right? I am able to reach this z using a different coordinate, that is radius r and an angle theta. So this radius r is called as the magnitude. So the name says that magnitude argument or modulus argument. So the modulus or the magnitude is r, and the argument is the theta. So instead of using x and y, I can use r comma theta to represent this z, right? So this z is also represented as r angle theta, right? So here r is equal to, let's try to find out how do you represent r. So if you recall, there is a 90-degree right here, so I can use the Pythagoras theorem. So this is x, this distance is y, so r square equal to x square plus y square. This implies r can be simply found by taking square root of x square plus y square, right? This r is called as the magnitude or the modulus, right? And I can find the theta, right? So theta is equal to, right? Uh, if you know the trigonometric identity, right, there is what a ratio called as tan theta, right? So tan theta is opposite divided by adjacent. Okay, if you have not studied this, it will come later, right? But as of now, we have to write one equation for this, right? So for that reason, it's a tan inverse ratio. Tan inverse of opposite is y, and adjacent is x. Okay, so this is y by x. So we can, if you know x and y, we can definitely convert them into r and theta using this notation. So this is the argument. Okay, so theta, remember theta is always measured with respect to the positive x-axis. Right. Now, depending upon different values of theta, right? Different values of theta, we can actually make them to be present in the first, second, third, and fourth quadrant respectively. Okay. Now, let us try to uh, measure some of the angles here, right? Let's try to measure the principal values of the following arguments. Okay, that is, let's see, convert the following into the r angle theta format. Okay, that's the question. We have to convert the given functions, given numbers into the r angle theta format. So the first number says z is equal to, this is 5 plus 5i. So 5 plus 5i is the number. So this means, let's calculate r. R is equal to root of x square, that is 5 square, plus another number, 5 square. Okay, so 5 square plus 5 square, it is 25 plus 25 is 50, root 50. Okay, please calculate the value for root 50. And we also need theta. Theta is equal to tan inverse of y by x. So y is 5 and x is also 5. So tan inverse of 1. Okay, calculator use madam. Okay, and calculate these two values. So in this case, r comes to be 7.07 and the theta value comes to be 5 by 4 radians. Okay, that's the first case. Now see the second case. Second one is, okay, the z is equal to, this is minus 4 plus 4 times I. So r we can calculate normally, there is no problem. Okay, so this, what should be the value of r? R is equal to, so previous answer will write in the format required. So the same z is equal to, I can write it as 7.07 angle pi by 4, or you can even write the degrees, no problem, 7.07 angle 45 degrees. Okay, these are the correct answers. Conversion of x plus iy into r angle theta. Now we want to do the same thing for this number. So this is root of minus 4 square plus 4 square. So this is root of 16 plus 16, root 32. All right, please find this value, root 32. Correct. So we get 5.65. But now remember, when we calculate the angle theta, right, there is a difference. So the difference comes into picture like this. See, consider this minus 4 and 4i. So which quadrant do they lie? I need to identify them first. So it may take some time initially. So I just time, but later on it will be fine. Okay, so this is y-axis, this is the x-axis. If you see, the x coordinate is not 4 comma 4, it is minus 4 comma 4. Right, so when you say minus 4, maybe this is the minus 4. Minus 4 comma 4 is here, right, which means this is the point z, correct? So if you connect that to the origin, and if you want to measure the theta, right, what happens? What is the theta which you are supposed to get? Right, I always want to measure this as the theta, correct? This is the theta. Theta is always with respect to the positive x-axis. But if you simply perform the tan inverse of minus 4 by 4, right, which is tan inverse of minus 1 will be minus 45, right? But the minus 45 degree is this. This is minus 45, which is the wrong answer. Okay, so ನಾನೇನ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ I have to always look at which quadrant is the number, which quadrant is the given z. ಈ ಕೊಟ್ಟಿರೋ z ಯಾವ ಕ್ವಾಡ್ರೆಂಟ್ ಅಲ್ಲಿ ಇದೆ ಅಂತ ನಾನು ಐಡೆಂಟಿಫೈ ಮಾಡ್ಕೋಬೇಕು. So that is my first step, and now I understand that this particular number is in second quadrant, correct? This is quadrant number 2. Right, how do you identify? Just remember, this is a quadrant 1. Other left side ಅಲ್ಲಿ quadrant 2 ಬರುತ್ತೆ, ಕೆಳಗಡೆ quadrant number 3, and here I have quadrant number 4. So if you have the number present in the second quadrant, right, then this is the formula. You see, ನಾನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡುವಾಗ ಬರೋ ಆಂಗಲ್ ಇದು ಬರುತ್ತೆ, ಬಟ್ ನನ್ಗೆ ಅದು ಬೇಡ, 180 minus that number, right? See, this total is 180 degrees. 180, subtract this angle, whatever you get as an angle, say 45, you subtract. The remaining is your required angle. Okay, so let's do that now. In this case, right, the theta is equal to, so remember, in only corresponding to this problem, this particular problem, theta is equal to pi minus, pi is 180, 180 minus, this is tan inverse of y divided by the so I'll just write magnitude of y by x. ಯಾವುದು positive ಯಾವುದು negative ಇದೆ ನನಗೆ ಬೇಡ, right? You can simply take the magnitude of y by x, correct? So for example, y positive ಇರಲಿ negative ಇರಲಿ ಏನೇ ಇದ್ರೂ ಕೂಡ ಈ ಕೇಸ್ ಅಲ್ಲಿ ನಾನು ಆ ಸೈನ್ ಅನ್ನು ಬಿಡಬೇಕಾಗುತ್ತೆ, right? Take y as positive, take x also positive. Or you can also even do that, this is instead of pi you can actually write 180, 180 minus tan inverse of magnitude of y by x. Calculate y by x, and if it is negative, neglect the sign. This is the formula to be used. So let's do that now. This implies, in this particular problem, let's do the theta. Therefore theta is equal to, this is pi minus, I'll do the tan inverse of, this is y is 4, x is minus 4, correct? So 4 by minus 4, its magnitude. So this is pi minus tan inverse of 4 by minus 4 is minus 1. Minus 1 is the magnitude ತೆಗಿಬೇಕು ಅಂತ ಬರ್ತಿದ್ದೀನಿ. So it is plus 1. Now you do that. You already know that tan inverse of 1 is how much? Pi by 4. Right? So this is pi minus pi by 4. Okay? So this is 3 pi by 4, or it is 135 degrees when you calculate in the degrees notation. 180 minus 45 is 135. Okay, so now you see the representation is as follows. Therefore the z is equal to minus 4 plus I4 is also equal to, right, what was the value? 5 point something, 5.65, yes, correct. So this is also equal to 5.65 angle 3 pi by 4 in radians, or it is also equal to 5.65 at an angle 135 degrees. And ಯಾವ quadrant ಅಲ್ಲಿ ಬರುತ್ತೆ ಅನ್ನೋದನ್ನ first ನೋಡ್ಕೋಬೇಕಾಗುತ್ತೆ, otherwise this answer will be wrong. Okay, you have to perform certain operation with theta, like addition of a pi or subtraction from pi, etc. ಈಗಿನ ಕೇಸಲ್ಲಿ we are going to subtract our answer from pi because I saw that this particular number is not in the first quadrant, it is in the second quadrant. So problem to solve now is this. First problem, z is equal to 2 plus I. Convert this into the polar coordinates. Okay, that's the next question. Minus 1 plus I root 3 represented in polar coordinate system. 2. The magnitude comes to be 2. Need to find the angle theta. So in the if you want to represent theta in radians, this is 2 pi by 3 or 2 angle 120 degrees. Okay, both are fine. Right, now let's move to the next type. This is z is equal to, this is say minus 3i. Okay, now let's consider the coordinate geometry once, just to understand the exact location of this particular complex number. So this is x, y. If you say this is minus 3, and if I say this is minus 3i along the y-axis, then the point which we are considering is in which quadrant? This is quadrant number 3. So whenever you are considering a point in the third quadrant, right, I am supposed to calculate this whole angle, correct? But when you simply calculate minus 3 by minus 3, I'm going to get this angle itself. Only this angle I get. Correct? So theta ನಾನು ಸಿಂಪಲ್ ಆಗಿ tan inverse of minus 3 by minus 3 ಮಾಡಿದ್ರೆ ನನಗೆ ಬರೋ angle ಇದು, right, between the negative x-axis and this given z. I just get that angle. So what I should do, I should actually add this 180 degrees to that. So this is pi plus theta. So pi plus tan inverse of y by x should be calculated in this case. Okay, so that's the only rule here. So anyway, first let's calculate r normally. This is minus 3 square is 9 plus minus 3 square is 9. So this is root 18. Calculate r first. Okay, that's right. So this is 4.24. Now, in order to calculate theta, when both x and y are negative, right, then this is the case. So theta is equal to either perform pi plus tan inverse of y by x. ಇಲ್ಲಿ magnitude ಬೇಡ, ಯಾಕಂದ್ರೆ ಎರಡು ಕೂಡ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. Y is also negative, x is also negative. Okay, or this is 180 plus tan inverse of y by x. You don't have to take a magnitude now. It's obvious because sign will get cancelled. That's correct. So angle comes to be 5 pi by 4 if you are measuring in radians. Okay, then let's go to the fourth case. Now this is case number 4. Or okay, before that, solve one problem now. So this is z is equal to minus all right, this is minus of minus root 3 minus I. Convert this into polar coordinates. That's correct. We get the value of magnitude, or the modulus is 2. Find the angle. Okay. So to calculate angle, what we are going to do, theta should be equal to, this is both are negative, so there has to be pi plus. Okay, pi plus tan inverse of y is -1 and the x is equal to minus root 3, right? So it cancel again, I just have 1 by root 3. Okay, so this is pi plus tan inverse of 1 by root 3 is actually, it's 30 degrees, so pi by 6. Okay, so this is 7 pi by 6 is the answer. Otherwise 30 plus 180, this is 210 degrees, or this is 2 angle pi by 6. In this case, we look at the z values which lie in the fourth quadrant. All right. So for fourth quadrant number, the z should be equal to, say this is 2 minus 2i. So first let's calculate the r in a normal fashion. So r is equal to root of 2 square 4 plus 2 square minus 2 square, which is plus 4. So this is root 8. Okay, this is 2.82. Right. Now, in order to calculate theta, we should understand that this, where is this number present, right? So where is the total number that is located? When x is positive and y is negative, the coordinate system is actually like this. So this is the x-axis, this is the y-axis. In this case, if you want to measure plus 2 over here, this is minus 2i. So see that this lies in, this is the given z, and this is the fourth quadrant. If you make a connection like say this, right? I know that the theta, whatever you measure, is itself is the direct answer, but it's actually going in the opposite direction. So this is a negative theta. Theta negative because with respect to x-axis, I measure a negative angle theta. So simply this theta is equal to, remember, only when this is when the number goes into the fourth quadrant, right? This is minus of tan inverse of magnitude of y by x. You take a magnitude and make it negative, minus tan inverse. So this is now minus tan inverse of, this is y is actually negative, minus 2 by plus 2, its magnitude. So this is minus tan inverse of 1. So this is minus tan inverse of 1 is either pi by 4, it becomes minus pi by 4, or this is minus 45 degrees. Right? Nama convention ಏನು ಹೇಳುತ್ತೆ ಅಂತಂದ್ರೆ, if you measure an angle in the anti-clockwise direction, that is right like this, that is a positive angle. Angle ಅನ್ನು positive ಅಂತ consider. Whereas you measure any angle in this direction, right, which is the negative angle. Now you see, if I measure this angle in the positive sense, it is actually plus 180 degree. ಅದೇ ನಾನು ಕೆಳಗಡೆಯಿಂದ measure ಮಾಡಿದ್ರೆ, the same angle becomes minus pi or minus 1, right? It's a convention, that's all. Both are right. There is no wrong, nothing wrong about it. All right. Okay. So using that convention, we are writing this answer in the following fashion. Okay. Then let's go to a problem. So z is equal to 1.93 minus I times 0.52. Okay, convert this into r angle theta format. The magnitude is 1.99. Find the angle. Theta should be, I can see that y is negative, x is positive, so this has to be minus, right? So negative tan inverse of magnitude 0 point minus 0 0.525, 1.93, right? So this is minus tan inverse of 0.26, right? So it can nಮಗೆ ಬೇರೆ ಮೆಥಡ್ ಇಲ್ಲ, I have to use a calculator. Okay, so you use a calculator to get this value. This comes to be minus 14.57 degrees. So the answer is minus 14.57 in degrees. Anyway, we can definitely convert it to radian by multiplying pi by 180. Okay, this is the answer. The next question is this. All right, convert the following term into its magnitude and argument. Z is equal to 2 plus I whole divided by, this is 4I plus 1 plus I the whole square. Right, so first we need to simplify this and then only we can do this. All right, so this is a 2 plus I. Let's simplify. This is 4I plus 1 square plus I square is minus 1, then plus 2I. Right, so the 1 and minus 1 will get cancelled. So this is 2 plus I divided by 6I. So as soon as I see a 6I, right, what I can perform, I can actually multiply and divide this with the 6I, right? 6I is fine, right? You can actually do it. Otherwise, actually, the problem will be simple again. So they don't do the multiplication because you know the answer. Actually, straightforward, you can write this. This is equal to, let us split the terms. So this is actually 2 by 6I plus I by 6I. Correct. You see, I cancels. What is 2 by 6? 2 by 6 is 1 by 3. And there is a 1 by I. 1 by I is a minus I. We already know that. I to the power minus 1. And this is I cancel out, just I have 1 by 6. Right. So you see, our term is 1 by 6 minus I into 1 by 3. This is the given Z. Now you normally calculate what is the magnitude of Z. Magnitude of Z is R, that is root of 1 by 6 square plus this is 1 by 3 square. Okay, first calculate the value for R. The magnitude is equal to 0.36. Now, since the y comes in the fourth quadrant, right? Sorry, y is negative, x is positive, so fourth quadrant. So theta should be equal to minus of tan inverse of y by x. So y is equal to 1 by 3 divided by x is equal to 1 by 6. So this is minus tan inverse of 6 by 3, so 2, right? So when you don't have a calculator, you can simply keep this answer because 2 is not a standard tan inverse function. Next question. Eight minus 4I divided by, this is 2 plus 3 plus 2i the whole square. Okay, this is the given z. Now convert this into r and theta. Okay, so always our procedure will remain same. I need to simplify this, right? We call it as a rationalization. So 8 minus 4i keep as it is. First simplify the denominator. So this is 2 plus, this is a plus b whole square, a square, 3 square is 9. Then we have plus b square, that is 2 square is 4 into I square is minus 1. So this is minus 4, then 2ab. So 2 into 3 into 2, that is plus 12r. This is the term now. So this is equal to 8 minus 4i divided by, so we have 9 plus 2, 11 minus 4 is 7. So this is 7 plus 12i. In order to simplify, I need to multiply and divide by 7 minus 12i, 7 minus 12. So numerator 56, 8 into 12 minus 96i minus 28i plus 48. I square is once again minus, so this is minus 48 whole divided by a square minus b square, 49 minus I square is plus 144. This is 56 minus 48 is 8, then minus 124 I whole divided by, this is 144 plus 193, right? Okay, 193. So calculate r. This is equal to root of 8 by 193. This is the real term, x value square, plus 124 by 193 whole square. Okay, the magnitude is 0.64. To find the argument theta, I can see that in this case y is negative, x is positive, so this has to be minus. Okay, tan inverse of y value should come first, is minus of 124 by 193 whole divided by, this is 8 over 193, 193 will cancel. So this is minus tan inverse of, what is the simplified answer? 8 and 124. This value is 15.5. ಇದನ್ನು ಹಾಗೆ ಉಳಿಸ್ಕೋಬಹುದು, you don't have to simplify, right? Okay. Next problem. Z is equal to, this is I plus 4 into, this is minus I, minus 1 plus 3I whole divided by, this is 16 minus 3 minus 2I the whole square. Solve this. So magnitude is 0.23, right? Find the angle. This is pi minus tan inverse of 0.67. Right. Now we'll look at some of the properties of this modulus function. All right. Properties of modulus or the magnitude. Okay. So here, let's say that let's say there is a function uh, z is equal to a plus ib. Right? If at all you take minus of the magnitude of z, right, or minus of that r value is always lesser than or equal to the real value of the z, okay, is always less than or equal to the magnitude of z. Okay, and the same property says minus of magnitude of z is less than or equal to the imaginary part of the z, that's also less than or equal to the magnitude of z. So let us understand this property, the meaning of this property. Let's say z is equal to, this is 2 plus I3. So calculate what is r. R is equal to root of 2 square, 4, 3 square, 9, correct? Root 13, correct? Root 13 numbers to the Okay, so you see that you get 3.60. So the property says minus of this value, magnitude of z, minus 3.6 is less than the real part of z. What is the real part of z? Is 2. Okay, this is less than the positive, that is 3.6. See, the first property is satisfied. And the real part ಎನ್ನುವುದು ಈ minus of z, magnitude z ಮತ್ತೆ plus of magnitude z ಮಧ್ಯೆ ಇರುತ್ತೆ ಅಂತ ಹೇಳ್ತಾರೆ. ಅದು ಕರೆಕ್ಟ್. ಎರಡನೇದು, let's try to find this. This is minus of 3.6 is also equal to minus of 3.6 is less than or equal to imaginary. What is imaginary part? That is 3. Less than or equal to 3.6. Right? So it is satisfied. It's always true. All right. Then the next property is this. The magnitude of z is also equal to the magnitude of z conjugate. That is also equal to magnitude of minus z. That is also equal to minus of z conjugates magnitude. ಈ ನಾಲ್ಕು ಟೈಪ್ನ ವ್ಯಾಲ್ಯೂ ಕೂಡ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆರ್ ದ ಮಾಡ್ಯುಲಸ್ ಒಂದೇ ಇರುತ್ತೆ, ಸೇಮ್ ಇರುತ್ತೆ ಅಂತ ಹೇಳ್ತಾರೆ. ಲೆಟ್ಸ್ ಟ್ರೈ ಟು ವೆರಿಫೈ ದಿಸ್ ನೌ. ಲೆಟ್ ಅಸ್ ಸೇ z is equal to 4 minus 3i. Okay, calculate its z. That's magnitude of z first you calculate, which is the root of 4 square plus minus 3 square. This is 5. Right. Now perform z conjugate. Z conjugate is 4 plus 3i. Now calculate the magnitude of this z conjugate. That is also 5. Now minus of z. Minus z in the sense this is minus of your number 4 minus 3i. This comes to be minus 4 plus 3i. That is minus z. Calculate magnitude of minus z. Root of minus 4 square is once again 16 plus 3 square is 9. So 5. Right? Then minus z is the conjugate. So minus z conjugate is nothing but conjugate of this is minus 4 minus 3i. This implies magnitude of minus z conjugate is also going to be root of minus 4 square 16 plus 3 square is 9. So that is going to give you 5 1. So you can see that all the 4 types of z which we calculated are going to give the same value. Right. The next property is the z into z star. Multiplying z with its conjugate, it's going to generate the magnitude of z whole square. Okay, anyway, we know that already we have it, right? Previous example only, we have the z and z star. You multiply both of them, you are going to get the same answer which we got just now. Okay, z, if you can verify this, ಆಮೇಲೆ verify ಮಾಡೋಣ, doubt ಬಂದ್ರೆ. Okay, let's move on. Magnitude of z1 into z2 is always equal to magnitude z1 into magnitude z2. In general, you can write, if you have z1 z2 z3 dot dot dot, you take a product and then take a magnitude. It's same as individual magnitudes getting multiplied. Okay, that is a proof, right? In the problems we might require this. Then moving on. Magnitude of z1 by z2 is always equal to magnitude z1 by magnitude z2. But note that the magnitude z2 cannot be equal to z, otherwise it becomes infinity. All right, then we have a property that is magnitude of z to the n is nothing but magnitude z raised to the power n. Okay, then next property is this. If you have any two complex numbers written in the following form, z1 z2 conjugate, this is plus z1 conjugate into z2, you can always calculate this as 2 times magnitude of z1 into magnitude of z2 into cos of the angle difference, theta 1 minus theta 2. So theta 1 is argument of z1, theta 2 is argument of z2. Right. And there is a specific case called as unimodular z. It indicates that unit modulus. What is unit modulus? This implies magnitude of z is 1. Whenever somebody says that, okay, z is unimodular, indicating that the magnitude of z is 1. Okay, these are the properties associated with the modulus or the magnitude. And after this, we have the properties of arguments. Okay, so the first property is argument of Z1 into Z2. I take a product Z1 into Z2 and I want to calculate what is the theta of that. Okay, theta one now argument anta kuda karite. So theta of the product Z1 Z2 is nothing but it is simply arg Z1 plus arg Z2. Okay, then argument of Z1 divided by Z2 is nothing but arg the theta of Z1 denominator ಇರೋದ್ರದ್ದು angle subtract ಆಗುತ್ತೆ. So this is arg Z2. Okay, and next important property of this is argument of Z bar or Z star. Okay, arg Z bar is equal to arg Z star. This is going to be negative of argument of Z. Whatever is a theta for Z, right? It's negative because conjugate will be on the opposite side. So opposite side ಗೆ ಹೋಗ್ತಿದ್ದಾಗೆ theta negative. All right. Let's calculate some problems. If arg of Z1 is 17 pi by 18 and arg Z2 is equal to 7 pi by 18. Right. So first let's calculate arg Z1 Z2 and arg Z1 by Z2. Okay, so how do you calculate this? Arg Z1 Z2 is nothing but, as per the previous property, it is argument of Z1 plus argument of Z2. So it's Z1 is given by 17 by 18 pi and the second one is 7 pi by 18. 24 pi by 18 can be simplified. 4 pi by 3. Similarly, arg Z1 by Z2 is equal to, right, arg Z1 minus argument of Z2. So calculate this. Arg Z1 is 17 pi by 18 minus 7 pi by 18. So 17 minus 7 is 10. So 10 pi by 18. 5 by 9 is the answer. Okay. So next question. If Z1 is equal to, this is 4I minus 3. Z2 is equal to, this is 6 minus 5I. Calculate argument of Z1, Z2, argument of Z1 by Z2, argument of Z2 by Z1. Okay, first I need to calculate argument of Z1. So Z1 is in, I look at that, it is in the second quadrant, so pi minus tan inverse of 4 by 3. Z2 is the second given complex number. I can see that it is located in the fourth quadrant, so it has to be minus tan inverse of 5 by 6. Are you okay? Any doubt? Now you look at the given question. The question says that if this is Z1 and Z2 are like this, what is arc, that is angle of Z1 into Z2? What is your answer? Simple addition, correct? So this is argument of Z1 plus argument of Z2, isn't it? So this is equal to, what is argument of Z1? This is pi minus tan inverse of 4 by 3. Then plus the next number, that is minus tan inverse of 5 by 6. This is the required answer. It has to be an angle. Argument of something means it is an angle. Okay, just remember, right? Answer cannot be a complex number. Answer has to be, right, some angle. So if I want to find the argument of Z1 by Z2, right, what's the form? Formula says arg Z1 by Z2 is equal to arg Z1 minus arg Z2. So arg Z1 is nothing but pi minus tan inverse of 4 by 3. Minus of that minus, which is already a negative, it becomes plus. All right, so this is tan inverse of 5 by 6 is the answer. See, this is also an angle. Then arg Z2 by Z1. This is equal to, now arg Z2 comes first, minus, this is arg Z1. So arg Z2 is a negative quantity, so this is minus tan inverse of 5 by 6 minus pi plus tan inverse of 4 by 3 is the required answer. Okay, all right. Next question. Okay, la doubt illala. If Z1 is equal to 4I plus 3 divided by 6I minus 7, and Z2 is equal to minus 2 minus 7I divided by 8 minus 3I. Okay, find arg Z1 Z2, arg Z1 by Z2, arg Z2 by Z. Very similar to the previous case. Okay, please try to solve this. ಇಲ್ಲಿ first ಏನು ಮಾಡಬೇಕು ಅಂದ್ರೆ there is a Z1. I need to calculate the argument of z1 or the theta corresponding to z1. But z1 is not straightforward. Z1 is actually, right, it's a ratio, right? So ನಾನು ಫಸ್ಟ್ ಆ ರೇಷಿಯೋವನ್ನು ಸರಿ ಮಾಡ್ಕೋಬೇಕು, ಆಮೇಲೆ ಮಾತ್ರ ನನಗೆ ಇದು ಮಾಡೋಕ್ಕಾಗುತ್ತೆ, right? So first let's write the z1 once again. This is 4i plus 3 divided by, I'll write the denominator in the reversed order, that is minus 7 plus 6i. Okay, now you multiply this, right? In order to calculate the theta, I need to first, right, rationalize. So multiply minus 7 minus 6i divided by minus 7 minus 6i. Okay, do you have any doubt in this step? No, right? Now can you multiply? What is the numerator ಅಂತ ಹೇಳ್ಬೋದಾ? 46i minus 21 whole divided by, this is minus 7 into minus 7, 49 minus I square is also minus, so plus 36. See the numerator, there is a I square. You can replace I square by minus 1. Correct. So the numerator becomes now minus of minus 24 is plus 24, right? Minus 21 minus 46i. Numerator whole divided by, right? The denominator is 49 plus 36, system power 85. No? Okay, this looks like 85. So the answer is 24 minus 21 is 3. 3 minus 46i divided by 85. Now this is the z1. Okay, now you calculate the argument of z1. How do you calculate? Look at which coordinate, which quadrant it is. X is positive, y is negative. So fourth quadrant, correct? Minus tan inverse of y by x, that is 46 by 85 whole divided by 3 by 85. So 85 cancel aಗುತ್ತೆ. It is minus tan inverse of 46 by 3 minus, okay, 15.3, right? This is the argument of the first one, z1. In the same process now, right, please calculate the argument of z2, right? z2 ಕೊಟ್ಟಿದ್ದಾರೆ, rationalize ಮಾಡಿ, get a simple z2 value. Then you look at which coordinate, where is the position, first, second, third or fourth quadrant. According to that, calculate a z2. All right, use that and write the z2. Okay, ಮಾಡ್ಬೋದಾ? So argument of z2 is minus tan inverse of 12.4. Okay, now use the property to get the value of arg z1 z2, right? Simple addition of the two numbers, right? So that is minus tan inverse of 15.3 minus tan inverse of 12.4. Arg z1 by z2 is nothing but subtraction of second angle, so minus tan inverse of 15.3, ಎರಡನೇದು minus ಇರೋದು plus ಆಗುತ್ತೆ. So this is plus tan inverse of 12.4. Similarly, argument of z2 by z1 is, right? So the second one comes first, that is minus tan inverse of 12.4. First one I am subtracting, so minus see there already, it becomes plus. Okay, tan inverse of 15.3. All right, so these are the required answers.